Hello. So after we successfully installed Python or our Anaconda distribution, we can start programming a little bit. During this series, we will go into detail into most of the beginners basic stuff that you will need. But just as an introduction, now we're going to write a simple program that does a very simple thing, and then we compare the different working styles, the different styles of how to interact with Python. One is just a command line. It's called REPL. We'll get to that. The other one is the interactive console, and yet another one is Spyder, the Spyder IDE, and another one that we are going to be working with for the rest of this series is the Jupyter notebook or the Jupyter lab. So let's start. If you're on Windows, you can go to your Start menu and click on the Anaconda prompt. That should look similar to this. Same in Mac OS. In Mac and Linux here, you can open any terminal or console, and depending on how you set it up, you should already have the base environment of Anaconda then selected. If we now want to start using Python, the easiest way is just to type Python and enter. If you get an error message instead that says Python not found, path not found, something like this, then please check that you're actually operating in the base directory or in the base environment of Anaconda. If not, go back to open the Anaconda prompt, and you should see something similar to this. And Python should work then. If you're on Mac and Linux, opening up any terminal, any console will give you a working Python, but this might not be the same Python version that you installed with Anaconda if you used it. The Python version is printed out here. Okay, so assuming this works, let's begin. Obviously, everyone should start with a hello world program. It's quite simple in Python. So we just write print and then in quotation marks as a string hello world, and we're done. What we see here, what happens here is we have something like an input line denoted by this 3 greater signs, where we can write something, right? And then afterwards, whatever we wrote there as Python code, is evaluated, and the result evaluated by the Python interpreter, and then the result is printed out. Then we start again with a new command that we can enter. This type of system is called the REPL, R-E-P-L. So the read, evaluate, print loop. It's exactly what it does, right? Python reads whatever you print there, whatever you wrote there. Then Python evaluates what should I do with this, right? And in this specific case, the print function tells Python to print whatever is given as a variable to the print function to print it out to the standard output, which in our case is hello world. And then we start again. It's a loop, so we loop over input, output, and so on. Let's imagine for a second we want to do something a little bit more complicated. We're going to go into detail about this later, but let's assume we want to write a little program that prints out the current date and time. Right? For this, we're going to use a module which comes shipped with Python, which is called the datetime module. So we have to import this, and datetime, and I'm going to give it a name just that I don't have to type as much as dt. So I now imported the datetime module as dt. About the import statement, we'll learn about this later a little bit more. Okay, now I have the dt or datetime module available, and I can just print the dt.datetime.now function. Then the now function is evaluated, and the result is then printed. If I do this, you'll notice it's quite late, but this gives you the current date at the time I'm recording this. Okay. How do you exit this? And now obviously you can do more stuff here, easy stuff. Everything you can do with Python, you can do in this console. However, it might not be as easy to remember stuff. You have to type a lot of things, and you don't have advanced features like auto-completion. That's why it's rarely you will use Python in this way. How do we get out of there? You can just type exit with brackets. Now we're back. Let's, for a moment, assume we want to do the same thing again. We want to again have the current time. Then I would, with Python, I would have to, with the standard Python REPL, I would have to type Python again. I would have to do the import datetime again, and so on. So it's not really an easy or nice way of interacting, because I have to type a lot of things. Luckily, we can save whatever we want to be run as a program as a text file, a Python script, if you will, and run this script instead. So let's open up a basically a little text file. I'm going to use the text editor Vim. You can use any text editor that you like. So I'm going to call this file telltime.py for Python. So that tells the computer it's a Python program. Right? It's just a normal, but from the structure it's just a normal text file. Okay, now my text editor is open here. I'm going to write the same as before. I'm going to write import datetime as dt, and you see I have automatically in this text editor of syntax highlighting as well. So the important statements are highlighted here, and yeah, makes it easier to read a little bit. So and now I want to do print the same thing again, dt.datetime.now, and that's it. That's my little program, right? I can also add something to it, make it a little bit more fancy. So just add in the print statement the current time is, and then with a comma append whatever we want to print afterwards. I'm going to save this file, and now I see that I have here this telltime.py file in there, and I basically recorded every step by step what Python should do and put it in this text file. And this I can now execute with Python telltime.py. The current time is easy as before. And now I don't have to remember it. I can extend this program. I can work with this. So this is an easy way to do something with Python, to write it into a script, and then you can edit the script by the text editor of your choice, and then run it with Python. Okay. However, there's more interactive ways of interacting with Python. So let's look into a couple of those. For this, we are going to use the Anaconda distribution, but this should also be available in your other environments. If you set it up yourself, then you have to, for example, install the next thing we're going to use, the Jupyter QtConsole, or previously called the IPython QtConsole. And let's have a look at it next. I'm going to click on Launch for the QtConsole, and you see it looks kind of similar to the thing as before. I'll make it a little bit bigger. So again here, we can also do the import datetime as dt. I have automatically syntax highlighting as well, and I can do also print dt.datetime.now. Oh, sorry. And I get the printout of this. Same thing as before. The benefit is, first, it's a Qt or QtConsole, which means I have more options. It's not just text. I can also have embedded pictures, and I have a little bit more advanced features like, for example, autocomplete. For example, if I can't remember how the print function was called, I can just type PR something and then hit the tab key on the keyboard, and I get automatically here a list of possibilities that Python recognizes. And I know it's a print function, so just enter, and then I can type whatever. Apart from that, I also, for example, have tooltips, which are quite useful. So if I type the print function and then open just a round bracket to initiate the function, basically, I get a little docstring, a little help function that tells me how to use this function. So I can print a value, and then I have some extra options that I don't have to use. But it's a basic function, so it's just print something. but it's very helpful if you're dealing with more complex functions and you can't quite remember how to use them. So the tooltips and autocomplete, very useful things to do. However, this is still just a console. So every time you want to start a program, you have to type everything in. It also has features like you can use the arrows on your keyboard to go up and down through the history that was saved in this, or that you previously entered in the QtConsole, which makes it a little bit more easy, but still it's a step-by-step process. Quite nice for introspection, but rarely used now because it's integrated in more advanced interfaces that we'll look into next. So let's close it for now. Control D, and yes, I want to close all. You can also click on File and then Quit. Close all. Okay, the next thing, which is kind of a symbiosis of a text editor and the QtConsole and a little bit more advanced features, is the Spyder IDE. So let's check this out. It should be installed already, then you can just click on Launch. If it's not installed already, you can just install it by clicking there. Okay, this is from a previous session, so this is roughly how it should look like. And for some reason I have a dark view here, or a dark theme here. And this is more of a program which combines on the left-hand side in the standard view, in the standard layout, a text editor with multiple tabs for multiple files. On the right-hand side we see a console and another window up here, another pane over here, with various things. So similar as before, I could just open here now my tell time from before. And I see now I have this untitled py, which is opened automatically, and then the tell time.py that we previously wrote in another text editor. You can just edit it here, and the time is, I can just change it to the time now is, instead of the current time is, and then just save it. And then now I have a text editor, and I can run whatever is in this text editor, run as a script, similar as we did before with the Python telltime.py in the console. We can now run by pressing this little green button here, or pressing F5, run file. And if we do this, what happens is whatever is written in this editor here, the whole file, will be sent to the console here, and each line executed one after another. So let's do this. And we see nothing else is happening, just the printout. The current time is now. The time is now. It behaves exactly as we imagined it would. Okay, we can also, let's just as an example, let's declare another web variable. A is 1.0. I'm going to save it and press F5. So same thing happened. I don't do anything with this variable, but I can show you now. By the way, this is the help browser, so you can browse similar to the tooltips that we saw before. Here in this browser you can read up on functions and get help. But the nice thing about Spyder is we have a variable explorer, which now tells us we have here a variable a with name a. The type is a float. We'll get back to that. And the value is 1.0. So it's quite a nice way, an overview of introspection into what your current program is doing. Right? This, however, refers to, because this is just a text file on the left-hand side, this refers to whatever has been done in this console here. So if I now declare a second variable, not in the text editor, but in here, and execute this by just pressing enter, I see the second variable is entered here. You can imagine that this makes it easier to interact with Python if you like this script-based approach to writing code and to executing code. Okay, this is as far as I wanted to go. Let's do one more example. Let's make a quick plot. For this, we're going to import matplotlib. We'll get back to matplotlib in a second. And then let's just plot something, plt.plot something from 0, 1, just two values, nothing fancy, 0, 1, just that we have a plot. and I execute this here, then I get this warning because I run this for the first time now. Okay, it's just that it's not, the figures are not shown up here or anywhere else. They're by default, there's a plot window here, or plot pane here, and that shows scientific plots, for example. So the Spyder IDE is kind of a scientific IDE, integrated development environment, where you combine a script, an interactive console, and some output windows here. It has much more than this. File browser and also the help functionality is quite powerful if you're interested in this. It also has nice debugging features when you have bigger programs where you need to debug, so finding errors. It's quite nice for this. Okay, but this is everything I wanted to share with you about the Spyder IDE. For the rest of the tutorial, we're going to be using the Jupyter Notebook, but more specifically the Jupyter Lab. So let's get into that. I'm going to close the Spyder IDE, and then we see these two buttons here. In your view, it should look similar. So you have first the Notebook and the Jupyter Lab. Let's launch the Notebook first, just to see how it works. I click on it, and a browser is launched. So my standard system browser, in this case a Firefox, is launched with this nice start page, which shows just my home folder, right? All the folders I have in my home folder, some files I already have in there. And now, yeah, let's directly jump to the Jupyter Lab because it's quite similar. So quit. The server stopped, so you can close the browser. We'll get into that later. So let's start Jupyter Lab, and you see that it's quite similar to this. Basically, the notebook, similar as the QtConsole is part of the Spyder IDE. Both the QtConsole and the notebook are part of the Jupyter Lab. This is how it looks like when you first start it up. So you have a browser on the left-hand side, and you have a launcher. It's called a launcher on this side, and you can already see there might be multiple tabs here. Then you have some internal on the internal. It's basically a web page that is shown here. Why that is important or convenient, let's say, we'll get back to later. Okay. So you have a little menu here where you can do different things. You can click, for example, a new launcher, but you can also do this via this launcher here, or start a new launcher here. You see this, you can close this pane or this tab and create a new launcher. And then we can start a new notebook or a console, a normal terminal, view a text file, we'll open a markdown file, a normal Python file. For example, if we do this, I get a little text editor, untitled.py is the file name. If I open a text file, any text is just a text file. I can also, if I click here our telltime.py script that we already wrote, if I double click on this, this opens in a nice editor. So you have everything you need, an editor, the notebook, everything in one little program. You can also shift the view. If you click and drag this pane here, then you can have side-by-side view. You can open up also like a little terminal, put it here. We need another launcher to make it more interesting. So you can customize your view however you like. Okay, so if I want to have the QtConsole or the equivalent in the Jupyter Lab of a QtConsole, we just click on console, and we see here we have now here the input line on the bottom, but the output will occur here. So if I print hello world here, now it's multi-line, so if I just hit enter, nothing happens. You have to press shift enter for it to execute actually. And now whatever was written in this line is printed out here, and the result is printed out in the next line. Okay, but let's concentrate on this notebooks. It's a very powerful tool. It's a kind of mixture between an interactive program like a console and a static program like a text editor. Let's see how it looks. First of all, it's empty. Quite empty actually. So let's fill it with something. First of all, what you see here is what's called a cell. There's nothing in it, but it's not it's not on the bottom as it was before in the console. And you can do multiple lines, multiple line edits here. So let's maybe import the datetime module as we did before. If I hit enter, then I'm still in this cell. If I want to execute this block, this code block, this cell, and just hit shift enter. And then it's executed, and now you see this empty brackets in the front here now have a 1, meaning this is the first cell that was executed. The order becomes important if you look more closely into it. Okay, now I can print do something like dt.datetime.now, shift enter, and I don't have to do the print because I can do the print. I don't have to. If I only have one command in it, it gives you the same. So now I have a second one, and because I executed this cell 2 times, it's 3 here. So this is the 3rd time, and now you kind of have an order. You know that this cell was executed before this cell, and so on. It's is important if you have multiple cells to keep track of what was executed at which time. Why this is so powerful and so nice, especially for data analysis, we'll get back to that. Suffice to say, what you can do is execute, for example, all your import statement at one time in one cell, then all your data import in another cell, and then you only have to import and run basically all this stuff that you only have to run once. But if you want to then plot something, for example, and make changes to the plot, make some analysis, do some fitting, something, if you do it as a script in an editor, you have to run the whole processing every time, because you run the script from start, basically. And here you can only execute one cell, and whatever was in this cell before is overwritten. But if you have read in data before, this will be present during the whole time, so you don't have to reread in all your data. So it's quite useful for data analysis especially. Okay, so this was everything I wanted to show you about the how to interact with Python. During the rest of the course, we'll look deeper into the Jupyter Lab and the notebook specifically. As a little homework, try it out yourself. Open up a notebook, try renaming it. Here, right-click and then rename notebook to something that you like, and just play around with it. What a kernel is and so on, we'll get back to at some point. But for now, I think it's enough to just get used to the interface. See you soon.